Okay, so me again, right? I'm just going to go through a few examples there now, so on the cosine rule. So let's have a look at this question here first of all, right? Find the length from A to B correct to three significant figures. So there's your A, B. Remember, we call what we're looking for A. So now, right, this is small a, this is big A, this is small b, or big B, small b, big C, small c. All right, so you have them labelled. Now, you now decide, will I use the sine rule or will I use the cosine rule to do my question? So I ask myself, do I know two sides and an angle in between? Two sides and the angle is in between. I'm saying yes to that. So immediately I decide I'm going to use the cosine rule. Is that a bit fuzzy there or faded? 1 second now. Let's see if I can fix that. So immediately I decide, right, I'm going to use the cosine rule. I know two sides and an angle in between, so I disregard my sine rule. So straight away, a squared is equal to b squared plus c squared minus 2bc cos of a. So straight away, what's my a? A is equal to what I'm looking for. So it's a squared is equal to b. 6 squared plus 8 squared minus 2 by 6 by 8 by the cos of a, which is 40 degrees. It's big A. So a squared is equal to 36 plus 64. 2 by 6 by 8. Now you can put that in your calculator. You could put the whole thing into your calculator. 2 by 6 by 8 by cos of 40. Right? So what have I got? 12 by 8 is minus 96 times the cos of 40. Now, of course, you could just put all that in your calculator. A squared is equal to 36, 64, 96 times the cos of 40. So it gives me 26.45973. A is equal to the square root of 26.45973. So get the square root. So A is equal to 5.1439. Correct to three significant figures. So three values of important, 5.14. Okay, so you can shove it all straight into your calculator for the easy ones. That's the first example. Going over then to example number 2. And here in example number 2, it says, triangle again, not right angles, we can't use SOHCAHTOA. Find the measure of the largest angle in the diagram correct to one decimal place. Now, the largest angle is opposite the largest side. So the largest angle is opposite 9, which is the largest side. So this has to be big A, this has to be small a. Right? Call what you're looking for either big A or small a, and it's an angle, so it's big A. We call that B, so small b, C and small c. It doesn't matter how you interchange the other ones. So I ask myself, do I know two sides and an angle in between? No, I don't know two sides and an angle in between. Or do I know three of the sides? Yes, I know three of the sides. So immediately I say I can use the cosine rule. Disregard the sine rule immediately. B squared plus c squared minus 2bc cos of a. So I have small a is 9 squared is equal to small b, 6.8 squared, plus small c, 7, 2 by 6.8 by 7 by the cos of big A. So 9 squared, now what I'm going to do is I'm going to bring it all to one side, bring everything over, minus 6.8 squared minus 7 squared is equal to minus 2 by 6.8 by 7 by the cos of A. So I'll evaluate that. 9 squared minus 6.8 squared minus 7 squared, and I get minus 14.24 is equal to minus 2 by 6.8 by 7, and that's minus 95.2 cos of A. Now obviously the two minuses here will make a positive, so it's equal to 95.2 times the cos of A. So then 14.24 over 95.2 is equal to cos of A. So what's 14.24 divided by 95.2? So 14.24 divided by 95.2 gives me 0.149579831 is equal to cos of A. I'm looking for an angle, so again, second function cos. Make sure your calculator is in degree mode. It says give your answer correct to one decimal place. So A is 81.39. So A is 81.4 degrees correct to one decimal place. Is that okay? If you're asked to give it in degree mode, you press second function DMS again. So there's two examples of your cosine rule. I'll do one more with you, right? So here we have example number 3. So we have a diagram drawn. There's a vertical pole, AC stands on a hill, right? Inclined at an angle of 8 degrees. So this is the angle of the hill. So see the line, right? So your angle, the gradient, the slope of the hill, right, is at an angle of 8 degrees. So the slope of the hill is not going to change as you're going up along. So when you go up along your hill, your slope will remain at an angle of 8 degrees all the ways up. So if that's 8 degrees in here, this will be 8 degrees in there. Isn't that right? So the entire angle here would be really 20 degrees if we needed it. Down the hill, 20 metres from the base of C. So down your hill, 20 metres from the base of C. So B and C down the hill. Lies a support wire is attached to the ground at B. So down the hill from C, 20 metres from C, you have B. If the wire makes an angle of 12 degrees with the hill, calculate the height of the pole H, correct to 2 decimal places. Now we're kind of bringing in our corresponding and our alternate angles here if we want it, right? We would see that if this line here is 20, then obviously the angle that we'll now, say if I was just to draw another line here parallel, okay? So a parallel line, well, it's not even going to be like that. Yeah, it is, right? It's parallel to this one really here, right? So this would be 20 here. This one here would be 20 degrees. Wouldn't that be right? So I'd have, if that's 20 degrees, right? This is 12, this is 8. We have our 70 degrees. So this obviously here is at a right angle. So 90 take 20 is 70. So 70 and 12 is 82. So 180 take away 82. So that angle there would have to be 98 degrees. So I've got a nice bit of information there. I have a triangle, right, where, can you see that? It is 98 degrees, 70 degrees, 12 degrees. This is 20. I have A, C, B. What am I looking for? Calculate the height of the pole. So H is what you're looking for, the height of the pole. Now you ask yourself, right, this time, do I know 2 sides and an angle in between? That and that. I don't know H, so that, no, I don't. I don't know these 2 sides. I don't know these 2 sides, so my answer is no. Do I know 3 of the sides? No. So I've said no both times, so I have to use the sine rule. So what's my sine rule? A over sine A is equal to B over sine B is equal to C over sine C. So call what you're looking for A, big A. Then you could have big B, small b, C and small c. So A is H, sine of 12 degrees, 20 over the sine of 70 degrees, C over the sine of 98 degrees. Cross multiply, H sine 70, 20 sine 12 degrees. So H, can you see that? H is 20 sine of 12 divided by the sine of 70. And there I'll get my H. So you can see the difference when you'd use either the sine rule or the cosine rule. So H anyway is equal to, right, it says 4.4251. So there's your H, 4.42, did it say? Correct to 2 decimal places. Now it's 4251, so I'll say 4.3. Right, and then find the length of the wire AB. So back again, I'll draw the diagram out. So here, the length of AB is what I'm looking for this time. I call what I'm looking for A. So this is 20, 4.43, 98, you have 70 and you have 12 degrees. So ask yourself again, you're looking for small a, so this here is big A. So do I know 2 sides and an angle in between? Yes, straight away I can say I'll use my cosine rule. So A squared is equal to B squared plus C squared minus 2BC cos of A. So A squared is equal to, this will be B, isn't it? And this can be C. So 4.43 squared plus 20 squared, 2 by 4.43 by 20 by the cos of what's A, 98 degrees. So A squared is equal to, and I'm going to shove all that in my calculator. So 4.43 squared plus 20 squared, 2 by 4.43 by 20 by the cos of 98, making sure it's in radian or degree mode. So 4.44.28637. Get the square root. So A is equal to 21.078. Rounding it to 2 decimal places is 21.08. All right. So there's 3 questions done for you now. So I'll mark questions then from your book after that.